All right, Mr. Morass, you've had long enough to stare at this problem. What's the answer?
For the car and the water.
We're in the water. Top one right here. It says water. Here's my information. Oh, I'll get my data set up if I can do it. Boom. Here's my data set.
S equals 3 would be 4.5 or 450 gallons per hour.
Uh-huh. How'd you get that answer?
Because that's what the Y is at.
Well, first of all, that's how much has gone through in the first 3 hours. It's hard to imagine all can go through at that moment or in the last hour. But this is going to be brutally hard, so please be with us. Seward! I moved on. Seward! What's your answer? How fast is water going through that gauge? At 3 T. It says T equals 3 somewhere? Oh, we already did this. Okay, so let me back up. That wasn't part of the question, T equals 3. And I didn't mean to interpret it that way, but he got the T equals 3 in there and slid it past me. Yes, ma'am. What's the rate at which the water's going through that gauge? It's different. It's changing. The whole entire time it's changing, right? It's constantly changing around. Is it not? Which makes the question bogus. So you have to ask what time. Okay, let me got we good here? Get it front row good? It's changing. You agree on that?
Yeah.
Okay. Let me then back up one more step. Ms. McDonald. She wants me to pick a specific time. Let's do T equals 3.
Yeah.
How fast the water going through at T equals 3?
4,500 gallons per hour.
So that's how much it does during the first 3 hours, agreed?
Yeah.
But that's not how much it's doing per hour, is it? How fast is it going at 3 hours? I have 4,500 gallons. We got 4,500. Sorry, I got 450 gallons going through in the first 3 hours. Doesn't mean I got 450 gallons per hour.
Yeah.
So at 3, how fast is it going through there?
Would you do the slope from 2, like the one before it, to find out?
Okay. If you did that, what would you get?
1 over.
Well, the rise would be 4.5 minus 2. So it'd be 4.5 minus 2 over 3 minus 2. And that would be 2.5, wouldn't it?
Yeah.
Or 250 gallons per hour. Great?
Yeah.
So you chose to use this data point and that data point.
Yeah.
What if you chose to use this data point to this data point? The stem rates, what would happen?
It would be 3.5.
8 minus 4.5 over 4 minus 3. You get 3.5, you said?
Yeah.
So which one's right?
None of them?
None of them are right. We know it's changing. Let's go back to Mr. Morast. It's changing the whole entire. How are you going to know how much water is going through at that moment? It's changing. It's changing. How are you going to figure that out?
How you gonna figure out it's changing, or how you gonna figure out
We know it's changing. How are you going to rate it 3? That's great. You know what derivative is?
I'm trying to remember, but it's like this.
So that we take a function and use the function to figure out what the rate is at that point. We don't have a function here, so that's not going to work at all.
What if you made a function?
Even if you knew how to do a derivative.
Okay, so what if you made a function?
What? We're going to make a function. We're going to enter a function. All right, let's go forward. Let's take a look. See, let's see if we come with a slightly better approach. A slightly better approach, not a perfect approach, but a slightly better approach. To do that, I'm going to go ahead and graph this. Everybody graph the data. Go ahead and graph the data. Slope of the graph is the rate at which the water is going through. You know how to find the slope. If I take 2 points on the line, you get to the rise of a run. Agreed? We did that in the front part of the page. It worked out beautifully. What's the problem here?
This isn't a line.
This isn't a line, which means the slope is doing what?
It's changing.
It's changing. Now I'm going to look over at everybody that's in the special list. The slope is changing. It's changing. The slope is changing. If the slope is changing, that leads to a really big headache, doesn't it? Because we don't know how to find the slope of a changing line. We don't. That's great. That's a great way to solve for where it is, but not what it's doing. And that's our problem. Okay? So the best we can do, if we really wanted to try this thing out, is we could say, well, it's kind of going like 2.5. If you pick these 2 points, you would get the slope there is 2.5. That's a lie. If you didn't pick these 2 points, it's 2.5. If you pick these 2 points, you get 3.5. Something like that, isn't it? It's the best we can do. That's a bummer. We like our math to give us nice answers, don't we?
Yes.
All right. Let me try the car's distance versus time measured below.
This one's weird. Feels like Do we find it by putting in our calculator?
You find it by putting your calculator? How would you find it by putting your calculator?
Put that information into a table and do some type of.
Do some sort of magic in your calculator? No!
Oh, I just can't.
How about we use that thing between your ears? There's a device in there. It's right about, it's right in there, in there somewhere.
Yeah.
The whole point, by the way, in this first half of this chapter is to understand why this works. Okay? The how comes later. But the why. What is it we're trying to do, and why are we trying to do it? Why do we care? Right? So again, if you do a graph of the points, you got a 0,
Isn't it just satellites?
9, and then and then R, and R, and then up to here, right there. So the graph looks something like what? Like this. Oh, I'm not letting you draw, so that's not great. Yeah? Something like that?
Wait, just to make sure, like, we just like skip the first one on this page.
Yeah, I skipped 0. I didn't skip 0, 0. The first question?
Yeah.
No, go ahead and answer this question. What's the speed rate of the car?
Wait, what?
What's the rate of the car? Go ahead, Stembridge.
No, I'm talking about the gallons.
It's changing. We don't know.
The what?
Like the gallons question. The one above.
Daddy, are we gonna go back to the first problem?
Oh, what we did is we said best we can do is what?
2.5 and 3.5?
So between 2.5 and 3.5, right? That's the best we can do right now. We know those are wrong, which makes it sad. How about this one here? What's the rate of speed of the car? I don't know. When? Okay, let's do 3 seconds. What do you think? 3 seconds, Mr. Rast.
3 seconds.
Yeah, 3 seconds. How fast is this car going? It's changing. Answer, it's changing. Correct answer is, I don't know, it's changing. It was going about 1 meter per second before. Its average speed before was 1 meter last second. Guys, these words are hideously important to some people in this room. If you got something you really talk about, grab a hall pass and figure out how to get share it, because I'm not going to let you do that. Okay? The average velocity before it was 1. Afterwards, it's 0. There's no guarantee this car didn't go forward and go backward, or gosh knows what it could have done. We're missing, we just got where it is. Stembridge, what do you got?
Confusion?
Good. Good confusion. Great.
Okay.
Great.
0 and 1.
Between 0 and 1, it was going fast.
No, I'm saying like the slope is between 0 meters per second and 1 meter per second.
The slope was an average of 9.
But at 3.
At 3 seconds? The
But-
3 seconds is this stretch right in here, isn't it?
Yeah.
1, 2, 3. It's right here, right? Where it goes from, it's basically starting to slow down, isn't it? Almost to a stop. It could be a stop for that next second, couldn't it? Before that, it's moving. So what's it doing at 3?
I don't know.
I don't know. That's the problem.
Yeah.
We have this massive amount of math. We spent years investing your math. You can't tell from this graph how fast that car is going. That seems unfair. We may have to figure that out. Yeah.
Is it the same as the first one? Like it's just in between the 2 points? But also, if the
It
car
was
was
going 1 before, 0 after. What is it doing at the point?
in between 1 0, okay, but can
Probably.
we? If it was
We have a choice between 1 and 2.
okay, but if the car was going in reverse, wouldn't it be like a negative slope?
Could be. Yeah. I'm not ready to talk about it just yet. That's next worksheet. We'll get there.
Okay.
Let me give you something to ponder. Let me give you a couple things to ponder. Who do I want? Stewart! If the speed limit was 6 meters per second, can an officer pull me over based on this data set? If the speed limit was 6 meters per second, can an officer pull me over?
Yes. What if they catch you?
Shh. Based on this data set. They watched me do this. Could they pull me over?
Oh,
How? You told me. We just said we don't know what the speed is at any time. Could you prove though the speed is something? It's at least what? For the first second, how far did it go? So at least 9 meters in the first second. That's at least 9 meters per second. I don't know what happened in between. It could have gone back. It could be even bigger than that. But it has to be at least 9, doesn't it? At some point, he has to be going 9. Okay? So therefore, I could pull you over for 6 meters per second. Oh, that's what officers do. They don't pull you over for going 45 miles in the last hour. They pull you over for going 45 miles per hour when they get you. Right? Those are different sentences. More on that later. Yeah.
How would you like properly write that it's somewhere between 1 and 0? Like, is there,
I don't think there's a proper way you know to write it just yet. We'll get there.
So we just write like on our worksheet. We just put.
Right, yes. I want you thinking. This data has value. You can tell it went faster than 6 at some point. You can prove that.
Okay.
But when we know it, we don't know what the number is. If we're there, we got pieces of it. We can say some things. We just can't say what it is. We can't say with certainty when the person looks down at their speedometer what the number says at 3 seconds.
Okay.
We suspect it's between 1 and 0. We're not even sure of that for sure.
Okay.
That's a problem. It's a bad thing. It's making us uncomfortable.
Yeah.
Because before this, we thought we knew how to do things like this. Yeah,
that's true.
it's true. Absolutely 100% true. All right, let's throw this at you. This next one is language. Why? It's calculus. Why would I care about language? I like wasting 2.